Okay, hello everyone again. Now we'll carry on with calculus. The second section we can go a bit quicker and try to just focus on the questions which are more different or maybe more difficult. So again, as you see, there's always this first principle questions. It used to be around 5 marks, but here you see it's 6 marks in this case. We'll check the memorandum together. Now after that the questions come with the application of derivative rules, and remember we have only one rule basically to find derivative of a function in this level, but we have to fix what was that fixing include. Like in this case I don't want x in denominator, that must be written up above, so instead of 1 over x it must be x to the power of minus 1, and that square is actually another problem as well. We don't want a product x inside the product, we must open the brackets. Okay, so we must open the brackets and we have to change 1 over x into x to the power of minus 1. After that this question can be solved, after that the rule can be applied. And in this last one here, as you see, first of all we must leave y alone, but there's another fixing, as there is root x inside the root, so that must be written as how x to the power of 3 over 2. So all these three type of fixings are in these questions. X should not be in denominator, x should not be written as a product, and x should not be written inside a root or cube root or anything. Okay, now let's quickly go through the memorandum and see if there's anything tricky or different. So writing f of x plus basically first principle rule as it is given in the formula sheet is this, and that's why we must write f of x plus h properly. That's 1 mark over there, and then substitute into the formula, subtract the original function, and that's why as you see it is written in brackets because the sign will change. And what was the story? All the terms without h should cancel, so whatever left we take h as a common factor, and the h's those h's cancel the one with denominator and the one above. After all, we can substitute h with 0, and we don't need to write limit anymore. In the last step, once you make your substitution with h0, then you can just write the answer, whatever left aside. Okay, so be careful with the notation, just understand this structure of solving and writing the answers. Now this application of rules, as we said, we have to open the brackets, and once you open the brackets, if you have difficulty in opening such brackets, maybe you can write it twice and apply that FOIL method. So 1 over x plus 1 over x times x plus 1 over x. So if you are having difficulty, nothing is wrong, as you can say x times x times 1 over x. So, but somehow we must end up, after simplifications, we must end up getting this answer. Okay, like 1 over x times 1 over x is 1 over x squared. X times 1 over x is 1, and there's another one, so they make 2. So we must get this step. And here it's not over. Remember, we don't want x in denominator as well. Instead of 1 over x squared, it must be written x to the power of minus 2. Now the rule is applicable. Derivative of 2x squared, 2 is gone, and derivative of x to the power of minus 2 is written there. Alright. And then the last one was, as you see, we left y alone. Okay, and this must be written properly as a power. And what about that z? Z is just a constant like k or 7 or 3 or negative 5. So like derivative of zx, because the x doesn't have any power, it just disappears, and we will only have z alone left there. And the derivative of the second part is kind of easy, 5 times the coefficient, and don't forget decrease the power by 1. Okay, then question 8, again there is a cubic function question, as you see, and we have, just like the previous question we solved, it is the coefficient of the x cube, x square, and x and constant term. We had to find them. Actually the question tells us this must be the answer for f of x. Now, what is given in the graph? We are given the x-intercepts, and there is a, which we can say as a double root. Okay, so we can say double root. That's why we will write it twice. because whenever there's an x-intercept at a turning point, or there's a turning point on x-intercept, then we will write it twice. So the general way of writing the function was a, x minus minus, so it's x plus 2 for b, but then for the coordinates of a, because it is double root, I will write x minus 1 twice. Okay, so because of b, we're writing that coefficient, that factor, and because of a, and since it is double root, we will write x minus 1 twice. Now, to find a, as in the beginning, so to find a, we need to make a substitution. So we must substitute a value, another point on the graph, we must substitute 2 and 4. Basically, that's my x and that's my y. So it was y is equal to this thing, and when I make the substitution, what is going to be written? We will write 4 is equal to 8 times 2 plus 2, and then 2 minus 1, and then 2 minus 1. From here we will get a, so a is going to be 1. Okay, that's fine. And then after you find a, we can just plug into the function and expand the brackets, open the brackets, and get whatever the answer is. Okay, now I want to spend more time with 9.2. So possible values for k if y is equal to 9x plus k intersect f. So that's a straight line, and 9 that we know is the gradient. Gradient is 9. That's a increasing line. And how does our graph look like? Our graph is a cubic function, and because a is positive, its shape is like that. As you see above, it is drawn. Now, when do we have a line which has gradient 9 intersect this? So we will be observing all possible lines with the same gradient. Let's say there is our line which has gradient 9, but it doesn't intersect. Now there's our line which is gradient 9. Now it intersects twice. Okay, let me just throw it from there. It intersects once, and then we may have a line which is gradient 9. So I'm just drawing parallel lines. They all have the gradient 9. So that may be intersecting twice or 3 times, and we may have another line from there. Let's see. Again, that will be intersecting twice, and we will have another line, and then which will be intersecting once again. So we are looking for what should be the k values. And what is k value, by the way? Y-intercept. Okay, so I am dealing with the conditions. Which conditions? So with the conditions starting from intersecting once, which is a tangent line, like in this case it's a tangent line, and in that case it's a tangent line as well. So anything in between, I'll be fine with such lines. Okay, I don't want it too much above or too much below. And what was k again? It's y-intercept. So it's all about y-intercept of the line. So if y-intercept of the line is in a proper interval, that will satisfy my condition. The question doesn't really say it intersects once or twice. Okay, so I don't care. As long as it intersects, we are fine with that. So our line, let's just make it like that. Our function comes all the way down. It may be intersecting once, and some of those lines intersect once, some of those lines intersect twice. But anyone in between will be intersecting, and all those lines gradient 9. So that gradient 9, okay, and this gradient 9, all these lines gradient 9. Okay, so basically I will focus the first and the last intersections. So those are the tangent lines I will focus. And let me just highlight those lines that I will focus. It is the line which is a tangent, and it is the other line which is a tangent as well. I want to focus those lines, and any other straight line between these will be intersecting. Okay, now, so how can I find those tangent lines? You see, the question pushed me the idea of tangents. And what is the keyword when you see as tangent as the keyword? When you seek tangent, you have to say we must have gradient is equal to derivative. Okay, do we know the gradient? Yes, we've been talking about all these lines as gradient 9. And derivative, yes, derivative of the function, I can get it. What's derivative of f of x? 3x squared and minus 3. 3x squared minus 3. Yes, that's the derivative. Alright, can I solve it? Is it a solvable question? Why not? Of course, let's solve it. So we'll get 12 is equal to 3x squared. So x squared is equal to 4. Okay, so nice. So we have two possible answers, which we were expecting, isn't? Plus minus 2. So one of those points, I can say, I can just write the points like A and B. Let's say the first time they intersect is A, that point. And the second time they intersect, the other tangent line is B. So I can tell you A has the coordinates of negative 2 and something, and B has the coordinates of 2 and something. So I got the two x coordinates of those lines where they intersect with those tangents where they intersect with the cubic function. Now how do I get the y coordinates? If I substitute into the original function. Let's do that. 2 gives me what? 8 minus 6. So 2 gives me 4. And then negative 2 gives me, just say 2 gives us 2 squared, so it is 8, so it's 4, yes. And negative 2, it's negative 8. And then plus 6, so it gives us 0, isn't it? So negative 2, it's actually B, you see, coordinates of B. Oh, there is already A and B on the graph. Let me just change the names then, sorry, because we already have, let's not say AB, because the question already has 2 points, which A and B. So we have 2 points, but as we see, negative 2 and B is our second point. We realize it later on. You see, I realize this point is B. The tangent line which gradient 2, I don't need to know at the beginning. That's why I could just say those 2 points. We don't really need to name them, but I know this other point is point B. It's the x-intercept. I can see that. And the other point is 2 and 4. Oh, it's actually C. So both these points were given. Interestingly, they already gave us those points from the graph. Now, okay then, how can we carry on? How can we get K? So we can find those line equations. So we can, because we have the points and they both has the same gradient. So gradient is 9 and point is minus 2 and 0. Gradient is 9 and point is 2 and 9. So what are the line equations? So I can say line 1, which is tangent 1, is equal to y minus 0 is equal to 9 times x plus 2. So we have y is equal to 9x plus 18. That's the first one. And the second line, line 2, let's say at C, line 1 is at B, and the other one is line 2 is at C. Then I'll substitute the coordinates of C. Y minus 4 is equal to 9 times x minus 2. So then we got y is equal to this time 9x minus 18 plus 4 is minus 14. So we got two possible lines. One of them is 9x plus 18. The other one is 9x minus 14. So that are my possible k values. You see, instead of that k value ranges in this interval. So I can freely say any k value between minus 14 and 18 is my answer. That's it. So I find those equations of the parallel lines, and from that, those equations of the tangent lines, and any k value in between will be touching more than once. Okay, if they are equal to negative 14 and 18, they intersect once, so I can make equal as well. Okay, if k is negative 14 or if k is 18, those are the tangent lines. If k is less than negative 14, those are the ones they don't intersect. If k is more than 18, those are the case they don't intersect again. So, and anything in between intersect twice. Any line in between intersects twice with the cubic function. So that's how you get the interval possible answers for k. Okay, there we go, the solution. I'll skip that. We have done it anyway. So this question, the application of calculus. Now such questions, I can just direct you. If you have limited time, you can actually solve 10.2 before 10.1. Because in 10.1 we are already given the area function, whatever the function is, a function. So I don't even read the question. I don't really care reading this question. I can just read 10.2, and 10.2 says what? Determine the dimensions of the container when the cardboard used a minimum. So area of cardboard will be minimum. So I am looking for minimum A. And when does this minimum A occur? Whenever derivative of A is equal to 0. So I will solve for it. See, I didn't read the whole question, nothing, but I can find the derivative of n, I can solve it. So let's do that then. Let's solve 10.2, and it's 6 marks. So A is equal to, it needs a small fixing because we don't want x in denominator, remember? So instead of 4000 over x, we write 4000 x to the power of minus 1. So that's A. So then what is derivative of this thing? Derivative of 4x squared is 8x, and minus 4000 x to the power of minus 2, and equated to 0. And this is already, we can say we have 2 marks. We got the derivative of A and we equated already to 0, and we need to solve for x and find the dimensions. That's it. Okay, let's solve for x. So solving for x, we must leave it alone. So what we do is you can take that negative 1000 to the other side, and x to the power of minus 2, I wrote it down. So then we cross multiply now. So it's 8x cubed is equal to 4000, and then you find x cubed is equal to 4000 divided by 8. So we can say it is 500. So x is, that dimension is a cube root of 500. So since we got x, whatever that condition is, then we can just figure out the other dimensions together. You see, okay, let's check the memorandum on the other side. Okay, as you noticed, we have a mark for making it 0. We have another mark for writing the derivative. So you solve for x. Okay, so cube root of 5000 is 7.94. So that is the length and the breadth. So they are equal anyway. And the last dimension is height. So that's like last mark, because to find height, we actually need to use that given information. So then the height is not just x, so it's 1000 over x squared, and that's how we got the dimension for the height. Okay, now let's come back to the first question. Then we need to read and understand the condition. A container in the shape of rectangle, the prism base in 1 liter milk, so it has a liquid 3 times the area of its base. So lid cover is 3 times the area of its base. The length of the side of the square is x centimeter, and the height is h. So we have h, and h as the height, and then the dimensions of its square, isn't all these dimensions are x, 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 x. Okay, that's a square base prism. So rectangular prism, a square base. So now hint, 1 liter is 1000. So that is how we can get actually h and a relation between h and x. So the volume formula in the prism you need to know by heart, base area times height, which is, okay, it's given in the question, but it may not be, so you must know it by heart. So volume area is base area, which is x times x, which is x squared times height. That's the volume area. So the volume is already 1000 centimeter cube. So 1000 centimeter is x squared over times h. That's how we leave h alone, and that's how we write x in terms of h in terms of x. And that's how actually you got the answer for that last step. You see, last step we got h. It was the calculator gave 7.94. So that's one dimension, the length and the breadth. But for the height, we used that first information because height is 1000 over x squared. So from here, you get the dimension for height. So it was 15 point something. Okay, that's how you get the third dimension. Anyway, so we got h, but now the question is still asking the area. Now, how do we get the total area which is used for this total area for the cardboard? for this box, rectangular prism. Now we have how many squares and how many rectangles. That's the point. So the square base has the area x square. So I can just say there's x square. Okay, there's another x square. There's another x square because there are 3 digits, and there's an x square at the bottom. So we have 4x squared. Okay. So for the area, we can say, so area will be 4 times x squared and plus, so we can just say 4 times the area of squares plus area of 4 rectangles. Okay, 4 rectangles has the same area as well, x times h. So then we can just say area is going to be 4 times x squared plus 4 times x times h. So it's almost done. To get 5 marks, we just need to substitute h in this formula for the area, and then we will get what they wanted. Okay, so that's the way of solving this application of calculus question. You can always go through with the memorandum when you see that. Now another papers, as you see, again first question, this time it's a fraction 2 over 3x. Now that first principles question can be asked most of the case. They ask with x square minus x negative 5x square and so on. It may be asked with cubic functions, just like x cube minus x cube. And this is the last type, actually the third type, let's say. It can be asked as a fractional form. But the method, the formula we'll be using is same. Just be careful how to find f of x plus h. So it is 2 over 3x plus h. And you subtract the original function as you see in the memorandum. The method is same again. Our aim is to cancel h so that we can substitute h with 0, and we won't write limit anymore, so we'll get the answer. Okay. So just study. You can pause and study this solution if you have any problem. All look nice and fine in this section here. Now 821, derivative of f is asked. Now it has to be fixed, the function has to be fixed because there is a square. And again, if you have problems taking square root, so what I mean is if you have a problem writing this part, which I will be shaded now in yellow, then please you can expand it, write it twice and open it up. So once it is written, the rest of the solution is kind of easy. So distribute 3 inside and then apply the rule that we only have. And then the last one seems a little bit more tricky because we have to leave y alone first. So let's say how it is done. So we must leave y alone, but you see y is inside the cube root. So to be able to leave y alone, we have to take the cube of both sides. So that's why y is equal to the cube of x squared minus 3. Now that makes our job a bit more tricky because it's not even square root. How can we expand it? So you have to write the expanded form. You must open the brackets. It's like x squared minus 4 minus 3 times x squared minus 3 times x squared minus 3. So once you get it, the last step is not a problem. You just apply that single rule. But then from expanding that x cube, just please be careful. It's kind of some algebra here. You can even write it a few times. Or you can memorize maybe this thing. I can just write as a note. Remember, in the first principles, if they ask a cubic function, you could be finding cube of x plus h. And what was it? It is the cube of x plus 3x squared h and plus 3xh squared and plus h cube. So with a similar idea, you can try apply that thing here. So we have x squared minus 3 cube. So it's the cube of the first term, which is x6, and then because it is minus now, it will be 1 minus 1 plus. So plus 3 times there is a 3 as well, so it's x4, yeah, and then plus 3 times now it is 9, so it is 27x squared, and then finally we have minus 3 cubed, 27. Okay. Or in any case, you can just open the brackets, writing 3 times that that x squared minus 3. Okay. So this was again the first principle question and derivative rules question. The only thing in the last one was tricky because we had to leave y alone, and while leaving y alone we cube both sides. Otherwise that's everything else is normal as it is. Now 9.1, we have some conditions given. Ax cube, a cubic function is given, yes, a is not 0. Now according to above information it says draw a sketch of g of x. Now then we need to understand the meaning of those values. Like it says the first one, first derivative positive, that means increasing in that interval, and first derivative negative, that means it's decreasing in this interval. So what does it mean in this interval and in that interval? Less than -3 and more than 3, it's increasing. So it's increasing less than -3, in between decreasing, and after 3 it is increasing again. So that's what I can say. So in between is decreasing. So that coordinate, I don't know what's it, is -3, and this coordinate is 3. And what's happening is it's increasing before -3, in between it is decreasing, after 3 it is increasing. So the shape of the graph is in this way. And then the third information is actually nothing different. That means we have turning points, because first derivative 0 is turning points. We already mentioned that. You see there's a turning point, yes, at -3. There's a turning point at 3. Do we know the y coordinates? No, not. It doesn't really matter. And finally, one thing, f0 is basically y-intercept. So y-intercept must be positive. Y-intercept must be above x-axis. So wherever y-intercept is, it must be above x-axis. So we can just plot x-axis accordingly on somewhere around the graph. And yeah, that's it. Any such graphs will be accepted. So that's an example. So you mentioned there's -3 as a turning point, 3 as a turning point, and y-intercept is positive somewhere above there. And then yeah, the shape you get marked. As you see, that y-intercept, once I draw this shape, for example, let me draw it again, that could be another possible answer. Like what? I can draw my y-intercept like somewhere here. That's 2 left, let me just do it here. And then x-intercept I can draw like that. So this could be another, oh no, it can't be, because it must be -3 and 3. Sorry. So I must have my my y-intercept passing through in the middle, isn't? Yeah, because what we know is this point coordinate is -3, that point coordinate is 3. But what we must do drawing x-axis is it must be below the turning below y-intercept. So that's why intercept become positive like that. So any such graph will be accepted then. That's my y-axis, that's my x-axis. Okay, and that's what they drew. And 9.2, that's again some coordinates are given. Now the function is not, some coefficients are missing, but we are given point D. Now point D, as you see, is a point on the graph, and as well as it's a turning point. So that gives us 2 information. Because it's a point on the graph, when we substitute 2 into original function, it must give me 54. And because it's a turning point, when we substitute 2 into derivative, because it's a turning point, that must give me 0. So that's my 2 equations to be solved simultaneously. Okay, so we'll get 2 equations to solve simultaneously when you make this substitution. Solve simultaneously. Then you'll get the 2 unknowns. We have, because we don't know m and we don't know n. So we have 2 unknowns and 2 equations. So it's enough to solve. Alright, so it must go in that way. So let's just go through with the memorandum. As you see, as the first case, we substitute 2 into the equation and make it 54. So that's our first equation. And secondly, we take the derivative, and when we substitute 2 into derivative, we equate it to 0. Okay, so I just want you to notice that first one, we substitute 2 into the function and equate it to 54. The second one, we substitute 2 into the derivative and equate it to 0. And so we ended up 2 equations. As you see, first equation is 18 is equal to 2m plus n. The second equation is 12 is equal to 4m plus n. So we have two equations. So just somehow solve them simultaneously. We can get the values. All right. And show that m and e. Okay, that's not a problem. Coordinates of f was the first question anyway. So it's when f of f0 y-intercept, as you see, f is y-intercept, it's 26, so 0 and 26. That wasn't a problem. It was just 1 mark question. But finding m and n, let me repeat again, which we said many times before. Do not make any assumption. Just solve it as like you don't know what is m and what is n, like what we have just discussed. Write those equations and solve simultaneously. Do not make any substitution or assumption as m is minus 3, or even in this way, like if m is minus 3, then we got n is 24. If n is 24, then m is minus, no, not even substituting one of them, none of them. Okay, just find them as how we solve it together. Determine the coordinates of e. See, from 9 to 2, let's say you couldn't solve 9 to 2, but I can use that values to solve 9 to 3, because for e, it's a turning point. I need derivative of the function and I have to make it equal to 0. So I can't do it, I can use those points now. Inflection point is the second derivative equated to 0. And when it is concave up, see, concavity is about inflection point. It is either before inflection point or after inflection point. And where is the inflection point? As you know, we have turning point D and turning point E. So inflection point is always in the middle of, somewhere here. Maybe it is B, I don't know, in the middle. So it depends whatever the position of E is. So it's exactly in the middle of two turning points. And in this case, what's happening is before the inflection point, we have concave up. And after that's inflection point. And after inflection point, we have concave down. Let me write down here, I think. So we have concave up here. And there's inflection point in between, in the middle. Then we have concave down. So the question asks concave up. So it is whatever inflection point coordinate is, that's before that value. Okay, let's check. Maybe it is B when it is solved. So the second derivative is 0 when x is minus 1. Okay, so it's not B. So actually the coordinates was minus 1. The way we plotted wasn't quite right. So the coordinate is minus 1 and 0. Oh, yeah, it's actually B. Yeah, exact coordinates of B. So the coordinates is minus 1 and 0. That's my inflection point. So I have concave up before that, concave down after that. So the concave up condition is x is less than minus 1. Concave down condition is x is more than minus 1. And inflection point is x is minus 1 and 0. That was 9 to 4. Okay. So we can use those informations in 9 to 3 in the following questions. Do not assume these values. Okay, don't make any assumptions. Alright, now that was the graph question. Now there is a question, again, application of calculus. Let's look at this as well. For we leave. A car has 4 liters petrol in the tank. Yes. After driving 80 kilometers, the car has 2 liters of petrol. So that's it was 4 liters, but then driving 80 kilometers, it's decreasing. It keeps decreasing as you drive the car. So that's obvious. Fine. Determine the gradient of the line. So that gradient, just like gradient in analytical geometry, we have 2 points. You can say one is 0 and 4. Before drawn, and one is 80 and 2. So you just find gradient between these 2 points. That's it. And then explain the significance of the value of the gradient obtained. So why is it important? It shows the decrease in petrol consumption, isn't it? If the gradient is lower, then there's a less consumption of petrol, or if it is more steeper, then that's a problem with the car then. So just that idea you need to explain. Okay, and we can even say like how many kilometers how many liters of petrol used in every kilometer. That can be calculated with the gradient. Okay, so that gives the idea of petrol consumption per distance traveled with this car, obviously. Now a graph question given, the equation is already given. Let's see, is anything different we can mention? Yeah, the graph is given, the equation is given, turning points asked, so first derivative 0 is the turning point, so then it is decreasing, first derivative negative is decreasing. Our answer should be what? Less than C and after A, because that's where it is. Oh no, we are looking for decreasing part, sorry. So our answer should be between C to A, decreasing. All right, then what else? Because it says decreasing, so those are the turning points. So basically first derivative, write the first derivative, equate to 0, then you'll get that answer for A and C. Equation of tangent at curve B. So we know the coordinates of B. I can just say coordinates of B is 0 and 25. I just need to get derivative. So derivative of that line at tangent line at B is derivative of the function. You substitute 0 into derivative of the function for the gradient. See, that's the secret of tangent. Gradient is equal to derivative. But at any point the derivative changes. So that's why we substitute 0. So otherwise the idea of derivative is equal to gradient is there. M is equal to the derivative of the function. So you substitute 0 to find the derivative. So we already know the point. So that's how we got the gradient. So then we can get the equation of straight line. That's the equation of tangent. Okay, that 914. Let's just think on this. F of x is equal to f of x minus k is equal to 0 have 3 distinct rules. You know how we can approach this question. We can just take k other side and then think about we are having parallel lines, just like we did this in function questions, in parabola questions in the function section. Remember, when our f of x is equal to k, it means has 3 solutions. So what does it mean 3 solutions? They will have 3 intersections. Okay, so f of x and y is equal to k has 3 intersections. That's what does it mean. So that equation has 3 solutions, means f of x and y is equal to k, that line equation, have 3 intersections. So what is y is equal to k line? It's a horizontal line. So this is my cubic function f of x, yes, and this is y is equal to k is the horizontal line. So how can we have a horizontal line intersecting 3 times? So then you will just take your ruler. You see, that's one of the examples. It intersecting 3 times. So any horizontal line between the turning points, we are fine with that. So when it is turning point, then it touches exactly twice. So like at C or at B, it touches twice. And above that line, above C, only one intersection. Below A, only one intersection. So that's the idea. I am looking for the intervals between y coordinates of the turning point. Okay, so we have 3 intersections in between here. So at that point, and at the y coordinate of C and y coordinate of A, so that's 2 intersection and 2 intersection. And then below A and above C, it's only 1 intersection and 1 intersection. That means 1 real solution, you can say. Okay, so as we have seen, can we see that? No, not in this, that's fine. So it's all about finding the coordinates of y coordinates of C and A. So when we have the y coordinates, we can say it must be in between. So let me just finalize that answer. K must be in between y coordinates of turning points, basically A and C, in their interval. Okay, so that is my answer for K. That's my interval for K. All right, good. Now 9.2, it's another kind of a neat sketch. Um, we have a graph of a cubic function, has turning points -1 and p, 2 and q. So what does this information say? Now that's increasing part because it's positive. That means when it is negative, in between it is decreasing. So this graph is again like increasing and decreasing and increasing graph. Okay, in between it is decreasing. So that the shape will be like this. Now G2, that's one of the turning points, so it's -1 and something. So -1 and p, actually that's m given, and this is n, 2 and p. So what we know is p is positive. So if p is positive, that means it's above x-axis. That means the x-axis must be below n. So that's how we should draw. Okay, so be careful in drawing this that way. So now we can complete. The function will come in this way. It's going down and up. And where is the y coordinate? Y coordinate is we can't just put anywhere, because you know that's 2, that's -1. It is in between somewhere there, in between -1 and 2. So y coordinate must be somewhere there. So that must be the shape of the function. Okay, that's g of x. Use your graph to determine the number of roots. You can just say only one. There's only one root. That means only one x-intercept. Okay, only one x-intercept, which means only one root. Okay. So what make us draw x-axis below n? So this last information, x-axis must be drawn below n. Okay, that information made us to do that. All right, I think all is fine. Now let's have, this graph is not for this solution. I don't know what for that. So, oh yeah, that's another different type of application of calculus. The function is given, rate of change questions, let's say that way, and there's the memorandum as well. Let's just go through. There's distance of a fixed point of a car moving towards a fixed point after t seconds. So s is a kind of distance taken, and t is in seconds. So determine an expression for the velocity. So velocity is always that first derivative of a displacement or distance formula. So when we take the derivative of st in terms of t, that's the answer. That's for the velocity. And calculate the time for which car was reversing. So that means it will be moving backward. So reversing is negative velocity. Okay, like you can say there is car and it's go forward. So when we have say forward, then we can say velocity is positive. But now if it is reversing, that means the velocity is negative, because going backward, it's all about the direction. So that's why we equate. You see, that's actually 1 mark to understand that. As you see in the memorandum, 1 mark to understand what they are asking is actually first derivative of distance must be negative. That means velocity must be negative. So you can actually, the question becomes solving a quadratic inequality. Just find the critical values. You know, it's like first question in algebra. But the most important part is to understand what does decreasing, what does reversing means. Reversing means velocity must be negative, which means first derivative of displacement function which is given is negative. Then the rest wouldn't be a problem if you understand that part. Okay, so anything tricky or different in this question? There's another K. Okay, now this was done. That's not a big, but it's actually the same question as we have done, the 25 and everything, or even this graph it's the same question. Let's skip this question. This question is let's see another application question maybe you'll like to go through. There is our question. If you just pause and read, maybe there are the points given, even the line equation is given, and the rectangle is there. So when they ask coordinates of Q in terms of x, so it's any point on the line satisfy the conditions for the line. Like we can say x is x, but then y depends on x. How can I write y? So it's basically we need to leave y alone in our equation. Okay, so what is y is negative 2x plus 6. So that's what we write. Coordinates of Q is x and negative 2x plus 6. So that's the coordinates of Q written both in with one variable in terms of x, and that's why I can tell you the height. For example, OR, the length is x, but then PO, the length will be in terms of x minus 2x plus 6, and then I can just get the area in terms of x. I can take the derivative and make it 0. See, all these stories come afterwards when you have that idea for the points and everything. Okay, under the line, so we can multiply them. As you see, that is the area when we multiply the dimensions. Let me put it yellow. When you multiply the dimensions, you got the area formula, and take derivative, make it 0. That's how we got maximum and or minimum, whatever they ask the situation is. All right, so that will be another application of calculus. All right, so we are about to finish, but maximum distance questions, like maximum length between two functions, two lines or two graphs, I just want to quickly go through a memorandum with this idea. Maximum length PQ, you see PQ is the vertical distance, so it's the vertical distance, and vertical distance formula is what? Y top minus Y bottom. So Y coordinate of the above line, subtract the y coordinate of the below line. Okay, so that's vertical distance. But now in such a case, it's like the above function minus the below function. The one above is the cubic function, which is f. The one below is the straight line, which is g, in that particular condition for PQ. So we will be actually generating a new function. It is the difference between two functions. So that's some kind of a new expression in terms of x, and the maximum, let's say that's our PQ. So for maximum PQ is basically whatever that function is, we will take its derivative and make it 0, and that will give us the maximum condition. The solution will give us the maximum condition. Okay, so let's just look 831. As you see, we are defined a PQ function. It is f of x minus g of x, so that's the difference function. So once you get it, derivative of this function should be 0. See, that's the derivative of distance function. So you equate it to 0, and the solutions will give us the possible conditions when you get the maximum distance. So you can just substitute those things into the function and find the y values in that interval, which one fits and which one gives us the maximum length, or whatever that answer will be, maximum or minimum condition they asked. Okay, so that was a bit different. And in terms of finding turning points, as the case above shown, like when you take the first derivative, you got a trinomial, you got a quadratic function, but now let's say you cannot factorize it. No problem, you can try to use quadratic formula and get an answer. Now if the quadratic formula gives error, like when you plug in these values, if you get error, just double check. If it still gives error, that means it doesn't have any turning point. Or if we are looking for x-intercept, it doesn't have any other x-intercept. Okay, so in this case, okay, we will be getting two values which are the two turning points anyway, but I am just mentioning whenever you are solving an equation, and if the quadratic formula gives an error, you know, then don't worry about, there's no solution then. You should be free to say that, but after double checking, okay, in case you make a substitution mistake or calculator mistake or anything. Alright, I think those are the few good things we mentioned in this question. Finding equation is not a big problem. You just open the brackets as you've seen. And as we notice that a value is 1. So that's given in the question. So you don't need to worry about a value because coefficient of x cubed is 1. So you can just say that and in finding the equation you can just use it, because sometimes the learner asks, what is a, or what other point do we need to substitute, okay, or so on. Actually this is given, there is other point is given in this question, it wouldn't be a problem, but that will be waste of time in solving. Another rate of change question, let me just zoom the question so you can pause and read, and I will zoom to solution as well. Nothing much tricky here. I believe you can read the question, and then when you go through the memorandum, all is clear enough to understand this question as well. So we'll be ending up with this question and with the calculus. I hope all is fine. It's a big section, 35 marks of paper 1, and I believe you get the most of these 35 marks. And there are some fixed type of questions like first principle, application of calculus, derivative rules, and then cubic function graphs and everything. Please read the questions carefully. That's another thing. If they are mentioning inclination or inflection point or decreasing, increasing, or derivative, just be careful reading the question and understanding correctly. And then I hope you get quite good marks in this section. Good luck.